All right, so today we're doing 9-1, which is solving quadratics by square root method. So we're using a note sheet for today's video and tomorrow's. So it's the 9-1 note sheet posted in Google Classroom. So make sure you have that to follow along with, a calculator if you need it. Let's go ahead and get started. Okay. So in this lesson, we're going to do taking square roots to solve equations. Now this works best when our equation is missing that b term. So remember, standard form is ax squared plus bx plus c. So we can use square root method when the b term is missing. So all we have is this squared term and a constant. So like we have an example a here. There's no plain x term. That's when we can use square roots. Okay. So the steps are listed here. We want to get the x squared thing by itself first. So our step one is always isolate or get the x squared by itself. So in this problem, they added the 98 over and then divided the 2 out to get x squared by itself. Once x squared is by itself, to get x alone, we would just square root both sides. Now, the one thing I just have to point out when you're taking the square roots of an equation, we need to include the positive and the negative roots. So we're usually going to have this little plus or minus that you see in front. Because technically, when we're squaring something, if I have, for example, 2 squared, well, 2 times 2 is 4. But also, if I take negative 2 and square it, negative 2 times negative 2 is also 4. So because we don't know if it's the positive number or the negative number when we take the square root, we just account for both of them. So we just write a little plus or minus in our answer. Okay. So let's do a couple of examples. In number 3 here, I have x squared minus 25 is equal to 0. So again, there's no middle term. There's no b term. So we can use square roots for this. So I'm going to start by just adding 25 to the other side. This is the only one where we don't want the other side equal to 0. So it's a little against what we're used to. But we want to get the x squared thing by itself first. Okay. So 0 plus 25 is just 25. Then to get x by itself, we need to square root it to undo the square. So that just gives me x. Square root of 25 is 5. Just don't forget the plus or minus in front. You could say the answer could be positive 5, or the answer could be negative 5. Okay. Let's look at number 2. So we have 9x squared minus 49 is equal to 0. So I'm going to start by isolating the x squared term. I'm going to get him by himself. So I need to do that in 2 steps on this one. I'm going to add the 49 over. That's going to give me 9x squared equal to 49. Still need to get the x squared by itself, so I'm going to divide that 9 out in front. Now, normally you guys would be used to taking the fraction with this and like getting a decimal. I'm going to just tell you to leave it alone. Leave it in this fraction form. Because if we look at 49 and 9, those are both perfect square numbers. Okay, so when I take the square root now of each side, we just kind of square root these separately. So for example, okay, the square root of 49 is 7. The square root of 9 is 3. So our answer here is 7/3. So plus or minus 7/3 is the answer. Okay. Let's do one more that won't work out so nice. So 25x squared minus 7. I'm going to do those exact same 2 steps as I did in the previous problem to get the x squared by itself. So I move the 7 over, and then I divide out that 25. And again, we're going to leave the fraction alone. So this becomes x squared equal to 7 over 25. And we're going to square root both sides to get x by itself. Now this is where I meant by it's not going to work out as nice, because we can't take the square root of 7. It's going to be a decimal. It doesn't work out nice. So instead, we just leave it, the square root of 7, divided by, since 25 is a perfect square, this one will work out nice. So we have the square root of 25 is just 5. plus or minus square root of 7 divided by 5. So sometimes they won't always be perfect square numbers. If that's the case, you just leave it as a square root. Now, if I could have simplified that square root of 7, I would have. But since 7 is a prime number, there's nothing else to do. So it's a square root of 7 over 5. Okay, we're actually going to skip this last one because you're never going to run into an example like this. And I don't want to make it harder than it has to be. So I'm just going to skip to having you guys choose or do these bottom two really quick. So in A, we have 2x squared minus 50 is equal to 0. So solve that for me by taking the square root on each side. So try that problem really quick. Okay, if you got it right, then for this number A, we should have got that x was plus or minus 5. So now try B. We have 4x squared minus 15 is equal to 0. Now 15 is not a perfect square, so it's probably going to be like number 3 above it, where it's not going to work out nice, but you could still take the square root. So try B and see what you get. Okay, so in this one I got x is equal to plus or minus the square root of 15 over 2. Okay. So again, don't forget those plus or minuses. They mean that we have two answers for these still. We just, instead of writing positive 5, negative 5, we just throw a plus or minus to make it a little easier. Okay. All right, flip this note sheet onto the back. And let's look at problems that look like this, where the x is kind of stuck in some parentheses. Okay, so it's the same kind of steps. We want to isolate the x squared term. It just happens to be in a parenthesis now. So we still want to get the squared thing by itself. So in this problem, they added the 25, or added the 5 over to get 25. And then we still square root both sides. So we square root. That gets rid of the square. We have plus or minus 5 on the right. But we have to break this into two separate equations. Okay. So we have x minus 5, or x minus 3 is equal to positive 5, and x minus 3 is equal to negative 5, and we solve for x. So these types of problems, it's not just going to be plus or minus a number. We actually have two equations to solve. So let's try a couple. So my first thing that I have to do is get the x squared thing by itself. Right now it's got a 2 in front, so I'm going to get rid of that by dividing it out. Like this. Okay. So here I have x plus 5 squared is equal to 32 divided by 2 is 16. So now, to get rid of that square, I need to square root both sides. So I'm left with x plus 5 equal to plus or minus 4. So here's where our two equations come in. We're going to have x plus 5 equal to positive 4. But we also need to set up an equation with x plus 5 equal to negative 4. So that's equal to plus or minus. And now we just solve each of these separately. So if I subtract 5, 4 minus 5 is negative 1. If I subtract 5 on my other equation, negative 4 minus 5 is negative 9. So there we go. Okay, let's try one more. I'm going to help you guys set this one up, and then you are going to finish it. So here in number 2, we have 4 times x plus 1 squared minus 25 is equal to 0. So again, I need to get that squared thing by itself first. So what I'm going to do is I'm going to add the 25 over. So now that's equal to 25. And then I need to divide that 4 out in front, because again, we need the thing that's squared, the one with parentheses, by itself. So we get x plus 1 all squared equal to this fraction. And again, fight the urge to kind of simplify this fraction. Just leave it alone, because I see that 25 and 4 are perfect squares. So that means when I square root both sides, okay, we're going to get x plus 1 No more square because we got rid of it. But the square root of 25 is 5 over the square root of 4, which is 2. Don't forget your plus or minus, because now we need to set up two equations. We have x plus 1 equal to positive 5/2 and x plus 1 equal to a negative 5/2. Now for these, you can use your calculator if you want. So let's see, if we have 5/2 and I subtract 1, you can give me this decimal answer, or if you want to turn your answer into a fraction, you can do that too. It's the same thing to me, it doesn't matter. So we get that x is equal to 1.5. On my other side, we had negative 5/2. So let me type that in. And if I subtract 1 over, we get negative 3.5. So there are my two solutions. So this one definitely is a little trickier on this side of the paper. Okay, since the parentheses kind of throw it off a little bit. But again, just get the whatever's squared by itself first, square root both sides, and then solve what's left. The front side's a little easier because it's just a plain x squared there. There's no parentheses that you have to worry about. So just get the x squared by itself, square root both sides, and then just don't forget your plus or minus in your answer.